Hello guys, welcome to Codamigo. In this tutorial, we will be discussing the main features that Typescript has brought to the table. So there's not going to be a Typescript tutorial. Rather, we will be focusing on the main features. As you might know that there were a number of problems with JavaScript. According to Microsoft, Typescript is a language that scales well. JavaScript was not well suited for writing large scale applications because as the code base grows, it becomes more and more difficult to manage JavaScript code. So Typescript came in rescue, which is nothing but a superset of JavaScript, which means given a valid JavaScript or ECMAScript file, just rename its extension to .ts and here you go, you have a Typescript file. The best part about Typescript is that it not only works on the front end, but you also can run on back end with Node.js. So Typescript is a programming language which is open source, maintained and designed by Microsoft. The browsers don't understand Typescript. They don't have Typescript engine, right? So Typescript must be transpiled into something that browsers understand, and that is JavaScript. This video is particularly useful for those who are good at JavaScript and have been working on JavaScript in the past and want to migrate to Typescript and wondering if there's going to be a good move or not. Oftentimes, I use Visual Studio Code, which has built-in support for Typescript. It provides auto-suggestions or IntelliSense along with linting. It is very easy to detect a number of compile time errors, which are very difficult to detect in JavaScript. So Typescript has made us a better developer, a better version of ourselves. It helps us write less error-prone and cleaner code, which can be easily maintained. The whole purpose of Typescript is to catch errors early on at compile time and not at runtime. Broadly speaking, there are two types of languages, dynamically typed and statically typed. When it comes to dynamically typed, we have Python, JavaScript, Perl, and Ruby. So let's say if you have a variable in JavaScript, you do not have to specify the type of it. The type of the variable will be determined at runtime when you will first assign its value. On the other hand, statically typed languages are those that ask you to specify the type of the variable before it is used, for instance C++ and Java, and of course Typescript. Apart from its amazing and very helpful type system, Typescript has brought onto table a number of other cool features like object-oriented features, interfaces, classes. It has generic capabilities. You can create generic functions and classes. It is very easy to organize your files. We have modules in Typescript and we can create and generate enumerated types. It supports lambda functions or arrow functions and all the features that ECMAScript has brought. Now let's head over to typescript.lang.org. So click on this button which says try Typescript now. And here you see that there are two options. First says that you can use Typescript in your browser via Playground, and second one says that you can try it on your computer via npm. We're going to choose the first option for now. As you can see, there are two windows. On the left hand side we have Typescript and on the right hand side we have equivalent JavaScript code. Let me delete everything that we have. Now let's create a custom type in JavaScript. And we have a type keyword that Typescript has. I'm saying that the name of my new custom type is marital status. This is going to be a literal type, meaning that this can accept only one value, which is single. If I create a variable of type marital status, I would not be able to give it any other value other than single. We have a union operator or pipe operator. We actually can combine more than one types in Typescript. So now I'm saying that the marital status can have two possible values, single or married. Let me add one more value to this. and we are done with our marital status type. Let me create this time an enum or enumerated type. Let's call it gender. We have two values, the male and female. If you are familiar with C++ or Java or Python, the first numeric value corresponding to male is 0 by default. So male is equal to 0 and female is equal to 1. You can see the same thing here on the right hand side, that male is given 0 value, female is equal to 1. Next, let me create one more enum and let's call it profession. And this is going to have only two values, just like gender, teacher and engineer. Teacher's corresponding numeric value is 0 and engineer's numeric value is 1, very much like gender, but we can initialize the value of enum in Typescript, very much like C++ and Java. So I can give it some string value. Now, teacher, the first value has some string associated with this, but engineer doesn't. So Typescript is yelling at me saying that the second value also must be initialized. Let's initialize this. And here you see on the right hand side, the second enum profession that we created is different from gender. Profession is very much like an object. Teacher is key, which is equal to teacher in all in capital, which is different from gender. So let's move on. Let's create an interface. Typescript has an interface keyword as well. Let's create an interface called person. Person going to have name, and I'm explicitly telling Typescript that person has a property name whose type is of a string. Name can't be number, it can't be date or any other thing. It has to be a string. Here we are reusing the new custom type marital status I just created above at line number 1. Let's create one more property. Let's call it gender. And you see that not only I am reusing my custom type enum, which I just created above, but I am also making it optional. This property or this operator is called optional property access operator, I believe. If we have an object whose type is person, then it is not compulsory to have gender. You can omit gender. That's what it means. We will see that in a minute. Let me create one more interface. Let's call it teacher, right? We have created a profession enum which has only two values. So let's do something interesting with interfaces. And I'm extending person, which is very much like a class extending another class in Java, C++, and even in Typescript. We will see that in a minute. We have one interface, person. So teacher going to be a sub interface and person going to be the super or parent interface. And I am explicitly telling that if there is an object of type teacher, then it has to provide gender. Gender is no longer optional here. And I'm also telling that profession can only be of teacher. It can't be integer. Let me define one more interface called engineer, which is very much like teacher. It has profession. Profession is engineer, but the gender is still optional. I am not forcing engineers to tell their gender, but if an object is of teacher type, then it must have gender, profession, name, and marital status. So for a teacher, all these four properties are compulsory to have, but for engineers can omit gender. Now let me create a person object which is of type person. I have to provide name, and it's saying that so I am like I haven't typed other properties. If I hover on person, it's saying that there are a number of properties on person object which is missing. It is declare it has name, but marital status is required. So let's create marital status, and now it is no longer yelling at me. Typescript has stopped complaining. So it has all the property which are mandatory. If I type, person dot or period, you see I have very nice auto suggestions or IntelliSense. I know exactly what properties are supported and the types. So if you hover here, it is also telling me the type, and the type of name is a string. Type of gender is gender or undefined, right? It may be missing. Okay, so let's create another object. Let's call it Peter, and I'm saying that Peter is a teacher. So it has to have a name. It must have gender, because for teacher it is compulsory to have gender. It has to have marital status, and the profession is set to teacher, right? What would happen if I say that the profession of Peter, who is supposed to be a teacher, is engineer? So let's try this out. It's saying that profession.engineer is not assignable to type profession.teacher, because it is expecting profession.teacher, teacher to be there. This is happening. If you look at the definition, we have said that profession can only be teacher. It cannot be engineer. Okay, so let's define one more teacher. Let's call her Dinah, and gender is female, right? So now I'm utilizing different enum, and let's say she's divorced and profession is teacher. And one last object, let's call it Harry. Harry is an engineer. That means for engineer it is not mandatory to have genders, so I can omit that. All I need to have are these three properties. I don't have to have gender. For printing, let me create a function. Let's create a print information. That's a function. This function is accepting only one parameter, which is of type person. It cannot be of any other type. I am telling that this function print information is supposed to return a string. It cannot return undefined, null, or any other value. I'm printing the information of the person given and returning the name of it, just for the sake of example. Clear out the console and print all these objects. Let me go ahead and click on this run button. And now here we have all the information of these people that we have just created. So this is the person, and here's the Peter, here's Dinah, and gender 1 means she's female, and gender 0 means that Peter is a male, and marital status and profession is engineer. So we have initialized that enum, the profession enum, with its string value. Okay, let me clear everything because we have more to discuss. So what we have just done is that we described or defined the shape of our objects and one function that we use. We no longer need to think of the properties an object has, and the type of the properties, and the number of parameters a function accepts, and their type, and the return value, return type of a function, right? Everything is available. You just need to type period or hover on the variable or object, whatever constant, whatever it is, and all the information is readily available. So defining data models using types, interfaces, makes your application data structure more clear, readable, and reusable, I believe. This will also help you make better design decisions. In a way, we can say that Typescript has enhanced our capability as developer. It has made us a better developer. Now I'm going to talk about one of my most favorite features that Typescript has to offer. That is generic, the ability of Typescript to create generic functions, generic interfaces, and generic classes. So let's see. Now let me go ahead and create a generic function. So for this, let's say I'm going to define a function. Its name is getTypeOf. If I want to make it generic, Typescript supports this syntax. So this is opening angle bracket and closing angle bracket, and I can specify the type that I do not know ahead of the time. You will see that how we can make it of number or a string or whatever type we specify, whatever type we give. You might have seen such syntax before, the T, but it is not a rule. I mean, you don't really have to have a single character. You can have any valid identifier. Let me also define that this function going to accept a parameter, and this parameter going to be of type item that we don't know what going to be the type. It could be number, string, object, date, function, and whatever we want to pass in. I am explicitly telling that please return a string. So it's going to return the type of whatever the parameter we are passing. It could be number, string, or whatever. So type of something always going to return a string. So now let's move on. Let's call this function with a simple string, Kodamigo. And here I am calling a method on the same string, character code at 0. That means this is going to pass in the character code of C. This time around, I am passing in the function. I am simply calling one function 3 times. You see that in first case we are passing string, in second number, and third function. We also can explicitly tell that type of function. I mean, we can specify the type that we want to work with. We still have the exact same output. So since so have a look at this line number 6. I have explicitly tell that the type, the item will be replaced by some string value. So this is same as saying that this is string over here and string over here, right? And if I try to pass in like something else, like some numeric value, like length, it would not work. So it's complaining. It's saying that the type number is not assignable to parameter of a string. This has to be string, otherwise it would not work. Just to demonstrate the power of generic functions, let me define one more function. It's called add. We are in a way overloading a method. Like we have one method defined and we are able to use it in 2 different ways. Just like before, it's a generic function. So the first argument is of type. I mean, we don't know what the type going to be ahead of the time. And we have second argument as well. And we are saying that this function is returning type. I don't know what type is. So first I'm checking the type of the first argument. If this happens to be number, then I am adding these 2 numbers, the first and the second number, right? So I can add first and second number. Now Typescript saying that it cannot, the plus operator cannot be applied on type and number. So Typescript knows that since we have this if statement, Typescript knows that the first variable is of type number, but it's not sure about the second. So we can forcefully convert it into a type. Now Typescript is not complaining about that, but it's complaining about something else. It's complaining about the return type, right? So this is number and this is also number. So ultimately we are returning a number, but here we're specifying the type, but Typescript does not know what type is. This is why it is saying that type, the number is not assignable to type. We can apply the same trick. We can use the as keyword and we can say that, okay, whatever we have is a number, but please return it as type. Next, let's do one more thing. This time around, I would like to concatenate 2 strings. Let's say first and second are 2 strings. So I am typecasting them. I'm saying that first is of a string. This enabled me to use IntelliSense. So if I type a period, you will see I have all the string related methods, right? If I don't use as a string, I would not be able to use IntelliSense. I have concat methods. Concat method is expecting a string, but right now concat does not know the type of second variable. So let me tell this explicitly that, okay, the second variable is of type string, and just like before, I'm returning the whole statement, the concatenated string. Now let's see how the add function is going to work with 2 different types of values. In first case, I am passing in 2 integers. In second case, I am passing 2 string. So in first case, it is supposed to add these 2 numbers, and in second case, it is supposed to add 2 strings or concatenate 2 strings. So let's click on run button, and here we go. We have 3 and Kodamigo. It has just concatenated these 2 strings. Let me clear out the screen one more time. Now let me show you another powerful feature that Typescript has, which is its ability to in a way organize interfaces and classes and other things, that is modules. So modules basically are a wrapper around your TypeScript code. They allow you to write, large scale code base at ease. Because when your code base grows, it becomes extremely important to organize things, to enhance maintainability and readability of your code. So modules are just for that. Now let's define a module in TypeScript. TypeScript has a module keyword, so let's call it namespace. And this namespace could be anything, it just has to be a valid identifier. And we have a class keyword. With the help of this, obviously we can create classes that were not possible in JavaScript before. So things are compiled into JavaScript, so still we are having, we have prototype based things, like every object has a special property called prototype, and which actually points to another object which forms a prototype chain. So under the hood, like, things haven't changed. All these keywords are syntactical somewhere. And the name of the class is private class. In TypeScript we have a read-only keyword. With the help of this we can create a constant instance variable. So let's call it name. This is of type string. Let's say it holds private class as a string value. Now I'm exporting a new constant. So here we have const keyword. We are using const keyword because it's not a instance variable. It is a variable outside the class. And let's give it a value. And here are two things to understand. So in the first example, you see that I have explicitly specified the type of this name property, right? If I hover on it, it says that name is instance variable of private class. So it's a property and its type is string. But if I hover on it, it's going to say that's a constant. It's a constant inside namespace. This basically is a literal type. This life variable cannot have any other value than 100%. Now let me create one more class. Let's call it exporting class, and I'm exporting it. That's why I'm calling it exporting class. So this is very much like a public class, because this class will be available outside the namespace. And this class also has name property, which is again read only. And here's the interesting thing. I'm using a property called private class, which is of type this private class. I'm not exporting private class because it's private, right? So from exporting class, I should be able to use private class. Let's see how. We have constructors, very much like C++ and Java, although I think in Java the name of the class becomes the constructor, but we have a constructor keyword. I think in C++ we have constructor keyword. This is how we define the constructors, and I'm initializing private class. So this private class is now instance of private class. Now I'm outside the namespace. Let's create a, this should not be var, but anyway, var works because TypeScript is superset of JavaScript. So everything that JavaScript has, TypeScript also has. I am instantiating exporting class, and this is the syntax: namespace and exporting class. If I type period, you see that only two things are available outside the namespace: exporting class, which is a public class, and live constant. In JavaScript earlier we had only two scopes: the global scope or the scopes that function creates. So if you have two scripts and if you have two variables, they are automatically part of the global scope. So the chances of name collisions are really high. And if you want to create a scope in JavaScript, then you will have to create a function and declare local variables and things like that. Okay, let's print out the object.name. So if I say dot, I have two things available, name and the private class, this property. Since private class has its own dot methods, so if I press period, I should be able to access it, right? So let me have another console.log, and I'm using object.private class, its name, and finally I'm using live namespace.live. Let's run this program. So the first statement says it is corresponding to object.name, which is nothing but public class, and here we are expecting private class, and then the value of namespace.live under person. So yeah, these are not all the features that TypeScript supports. So we have just scratched the surface. TypeScript is way more powerful than JavaScript, and I would highly recommend you to start learning it and try it out and write your next project in TypeScript. If you found this video useful, please hit the like button, and if you are new, you haven't subscribed the channel, please don't go before subscribing this channel. So with that said, I'm signing off, and I'll see you in my very next video.